In this video, we learn how to apply the expected value operator for a concept of variance for discrete type random variable. So we want to know how we can calculate quickly the variance of a discrete type random variable. So basically, the variance is defined by the probability mass for a discrete type random variable and the deviation of the location from the center of the distribution to the power 2. So you basically calculate the summation, and pi is the probability mass function. This is the probability mass function. So that means that at location xi, you have a probability of pi as a mass, and you have, let's say, x1, and let's say etc. So let us have one example. Suppose that we have an indicator random variable for any event A. So we know that at two locations we have mass, at location 0 and location 1. At this location I get P1 is equal to probability of A, and here P0 is equal to 1 minus probability of A. Okay, so the mean is equal to the location times, so this location I multiply it by this one, then this number multiplied by this number, I get mean. So this is expected value of indicator random variable A is going to be the location times probability, and then I add everything together. So this is mean of A. The variance, I could calculate first the mean of IA to the power 2. Basically, I of A to the power of 2 is equal to, because this guy is either 1 or 0, so you get 1 to the power of 2 is 1, and 0 to the power of 2 is also 0, so this is equal to I of A. So in general, an indicator random variable, IA, even to the power of any integer numbers, is equal to I of to the power of 1 of A, except n equal to 0, or non equal 0, for any other n is also equal. So you could quickly verify that this is equal to this one and this one is equal to that. So basically, if I want to calculate sigma 2 of IA, I say equal to mean of I A to the power of 2 minus mean of I A to the power of 2. So this is equal to probability of A because of this guy, and this guy is minus probability of A to the power of 2. So this will become probability of A times 1 minus probability of A. Okay. So the variance of an indicator random variable is always equal to probability that event happens times probability that that event doesn't happen. Okay, so what we got here is that here is 0, here is 1, here we get probability of A, here I get probability of A bar. So you multiply these probability masses together, you get the variance. Obviously, the variance is 0 if probability of A is 0, or probability of A is 1. If probability of A is 1, also the variance is 0. If you know that what is the outcome of A, if A is happening all the time or is not happening all the time, the variance is 0.